Hey everyone, and welcome back to the channel. This is the second part of my in-depth review of the new RIGOL MHO98, the flagship model in RIGOL's brand new MHO900 series of higher resolution oscilloscopes. If you are just joining in with this video, I'd strongly recommend pausing here and watching the first part first. You'll find the link in the top right corner of your screen. On the other hand, if you already watched part 1, you may skip the intro and go directly to the next chapter. The RIGOL MHO98 is a very limited celebration edition, and by the time you are going to see this video, it might not be available anymore, so everything you will see in this video will also apply to the standard production model, except the 1 GHz analog bandwidth, the licenses, and the included Logic Analyzer Pro. So if you can still get the MHO98, don't hesitate, it's a bargain. So in today's two-part video, I'll not only take the MHO98 through its paces, but I'll also compare it side by side with its more affordable sibling, the RIGOL DHO924, to see just how much extra performance and value this top-end model really delivers. Before we dive in, a quick note: RIGOL provided the MHO98 for review, but no payment is involved. I don't follow a script and all observations here are my own. When this video goes live on YouTube, RIGOL will see it at the same time you do when it's published. Thank you RIGOL for sending it, and thank you my viewers, the real sponsors of this channel. If you like what you see and decide to pick one up later, please use the affiliate access links in the video or in the description when shopping on AliExpress or Amazon. It won't cost you a cent more, but really helps to keep this channel going. The channel also has a discount coupon code to use on RIGOL's website, applicable to any equipment available there. Alright, all disclaimers done, let's continue with the comprehensive breakdown of the MHO900 oscilloscope series. Allow me this small break to send kudos to this video sponsor, PCBWay. Being a leader in PCB fabrication, it is able to manufacture with very low price and in record time the PCBs for your project. Don't believe me? Just take a look. You get 10 PCBs double-sided for $5. It's hard to beat this. But that's not all. You can even create your project parts like custom case with their injection mold service or 3D printing, not to talk about their professional CNC machining service. It's a one-stop supplier for all your project needs, and if you use the code below on the screen, you will get a $5 discount on your first order. To demo the FFT function, I have already in the screen a square wave. This has a VPP of 3.3 volts, more or less, as you can see on the screen, and it has a frequency of 10 kilohertz. Okay, let's take this out of the screen. We don't need it anymore. Remove all. Yes, okay. And to see the FFT signal with the harmonics, let's activate a matte channel, like we previously did, and came here to hamburger option and set this to operator to FFT. It is already there. Okay. We have the spam center already activated. The center will be at 30 kilohertz. Okay. Let's leave this in Hanning, the window, and in terms of span, let's put 60 kilohertz. Okay, and we have harmonics on the screen already. We can even activate, but let's first see. We have here the harmonics on the screen. So let's see what other options we have. We can put it directly on the main screen also, with both signals at the same time, or we can take this out and activate also the color grading. And this will show you where the most values are hit. Okay, in terms of color grading. This is also a very nice function to have. Okay, so but in terms of the FFT, this is basically how you can handle it. You can have the modes as normal, average. You can see that right now the lines are much softer and the harmonics are more defined, and the max holds also. Okay. Again, since we are in math functions, we can have up to 4 windows with this kind of analysis. And yeah, I think that this mainly covers the FFT function. I have already a square wave with some distortion in the screen, and this is to show you a function very useful to compare signals. I'm talking about the reference, the reference signal, and you have a whole system for that here on this RIGOL. You can have up to 10 reference signals, and you can select for each one the channel, including the math channels that you want to save as reference. Let's take this one that I have on the screen right now, and let me just, before we save it, tell you that you can also set a name for it. Right now it's ref1, but it can be anything that you want. You just need to type what you would like to call it. So let's start to save the reference. Okay, it's saved, and you can see it here already in orange. That's the color that was selected. You can also import the reference that you saved previously from the disk if you want to, and you have several options here. You can export, for example, if you want to save this reference, or import it, as I just told you. Okay, let's see the reference. We have it here. Okay, right now this is the reference signal, and if we come to acquisition menu and set the average like 16, like we already did in the acquisitions chapter, we can see that the signal right now it's very different, and using the reference you can compare it with the previous one and take a visual note, or even you can use cursors, measurements, everything to measure the differences in terms of the signal that you have on the screen. So this is very useful to compare signals. You can have, as I told you, several references. So let's see if I want also to take a reference signal from this one, let's say the 2, and I want this one to be like light blue. Only thing that I think it should have more colors. We have few colors for 10 signals, but yeah, light blue. Save to reference. Okay, and we should have right now a second signal available for comparison. Okay, let me put it here, and if I go again to normal, you can have the comparison of the signals. For example, if you do a high res, this will be the signal. Let's do a single. So this will be the signal with normal acquisition, with high res acquisition on yellow, and on blue you have the average. So you can compare the signal with several options available. Okay, it's not complicated to use, very simple. The only thing that I've not shown yet is that you can save. I mentioned but didn't show how to do it. You can save it to bin CSV or reference. You can put a name of your choosing in it, and you can save it to local disk, or if you have a USB disk, it will show here. Okay, you can save it. It takes a bit, not much, and then if you want to import it again, just press import and you go to local disk and load the file that you just saved. So in terms of reference, this is what I have to show you, so let's continue. In this system you have also the counter for counting the hits you have of the signal. You can activate it here on the top menu with the counter option, or in the menu again, the RIGOL menu. you have also this option available. So let's open it, and it's pretty simple. It will say that the counter right now it's counting 1.008 kilohertz in terms of frequency. In terms of the counter, you can have several options. You just need to press with the finger in this box where you have the counter. You can reset the statistics or the settings. You can also select it with the mouse cursor, obviously clicking. And let's see the settings of this. You can select the source for the counter, and you can activate the statistics for what is being counted. So in this case, the frequency. In terms of measurement, you can count the frequency, the periods, okay, and also the total hits that are being counted. Okay, you can clear the counter, and in terms of the frequency, you still have the resolution as a configurable option, periods also, totalize, no. So, and that's the options that you have for the counter. Nothing special, but quite useful. Still using this square wave on the screen, we have the DVM, digital voltage meter. So this can be activated on this menu as I just did, or you have it also here on the top. So this function will allow you to see the voltage of the signal that is being input in the oscilloscope. You can have also several settings for this. Obviously the channel that you want to measure the voltage. If you are using AC, DC or AC plus DC RMS, so DC AC RMS signal, if you want, it will give you this value. DC, it's the one that we should use right now. Okay, and in the end you have AC plus DC, it will give you this result. So in terms of the rest of the options, you have also the beeper that can be activated, and when you activate the beeper you can say if it will beep if the in limits or out limits, so if the range is inner or outer, and you can set the limits of the range with upper value and lower value. And yeah, that's it. So what will happen is it will beep if the values that are being input are out of the range selected. Now is the time to talk a bit about the logic analyzer probe. This is the PLA 2216. As you can see, we have 16 digital ports that you connect with these cables that has a claw in the end, and these allow you to analyze at the same time 16 digital channels. So this probe has this connector. It looks like a EDA cable or EDA socket, if you know. And if you are from the SCSI time when connecting drives, this one seems one of those cables. It has a lot of connectors. So this one goes into the oscilloscope. Let me connect it. As soon as you connect, it will detect the probe. Let me take this out of the screen. And in this end, in the probe, we will connect these DuPont cables here. Okay, the SDA in my case go to position 0 and SCL goes in position 1. For safety, I will connect in the bottom line this DuPont cable that is connected to the ground of the board. So all these channels in the bottom are ground, as you can see. Let me take this out of the way. I have the board with the claws already in place, and we will decode a I2C signal. For that, let me start, and we have a lot of cables here in the way. Let me clear so you can see better on the screen. To work with the protocol decoder and the logic analyzer, first of all, you have here on the keyboard a button to activate the logic analyzer, but you can do it also clicking in this zone of the screen where you have the L. Okay, let's press the button LA, and as you can see, the first thing that happens is you will have the 16 digital channels in the screen from the 0 to 15. We don't need all of this, so I will remove some of these channels. For that, you come here to the logic analyzer option, and for example from 8 to 15 I don't have anything connected, and also I only have 2 channels right now connecting the first two positions. I previously set the threshold to 1.6 volts. And in terms of configuration, let's put this in large. Okay, so we can have the lines in small, medium or large. I prefer the large, that's it. Okay, in terms of label settings, we can also customize this. For that, just come here. In this case, I want 0. So the D0 is the SDA. Let me just configure SDA. Okay, and D1, okay, is SCL. Oops. SCL. This will help while analyzing the signals. Okay, and you can see them here, the labels on the screen. So we have the logic analyzer set up for working. Let's close this and go to the decoder part. The decoder, you can access it from the top menu as always, and also in the RIGOL logo you have also the decoder in here. Here it is. We have here the decoder. We have 4 decoders available. Let's start with the first one that I want to be a I2C decoder, and also the clock will be D1 and the data will be D0. I want this to be decoded to ASCII, SCL to SDA. This is correct, but if you get it wrong, you can invert here. Okay, 7 bits, label. I think that we are good to go. Let's enable the decoder. Okay, and we can see already in the screen. Let me just bring this to 2 milliseconds and activate here the event. Okay, we need also to activate the buzz. And when we activate the buzz, let's move this to bottom. It will be easier to read. You can see here on the buzz status bar or line the values being decoded. This demo board for the testing outputs European city names, as you can see, and we have a few there. And also in the events table, you can see here the city names changing, both on reads and on write. So this is really nice to have. Also, you can set up, well, we can stop it. For example, you have here Italy, and you have also here Italy, but you can also trigger this just going to, for example, what we want I2C, and the channels, in this case SCL is D1, this is D0, and I want address and data. Okay, this should be enough. Let me put in normal. Here it is. And we have, whenever he finds a data and an address and data packet, he will trigger. Okay, but let's take this to auto again. As you can see, the decoder works pretty well. This board is also nice to test this kind of devices. If you are buying a model MHO900 series that will not come with default with this probe, then you can also do the decoding using the 4 channels of the device. For that, you just need to come to the configuration of the decoder, and instead of using a digital channel, you will use one of the analogic ones that you have. So up to 4 channels will be nice to do this kind of debugging. If you are not interested in buying this probe that costs around 200 and something euros, so it's totally understandable. It's a good investment anyway. But okay, in terms of logic analyzer and decoder, we are done. The pass-fail system is a pretty neat feature that you have in this device. And let me show you how it works. We have here on the RIGOL menu the pass-fail. Not sure if you have on the top, I don't think so. Let's check. No, you don't have it. So you have here on the RIGOL menu the option pass-fail. This is a system that will allow you to check if a waveform will pass according several parameters that you define. Let's agree that right now we have a wave on the screen, and according these parameters it will fail every time it enters this blue zone. But this can be configured in several ways. Let me show you. If you come here and do settings. Okay, so now we have this window configuration where you have the enable, obviously. Right now it's enabled, and you can select the source also. You have the coordinates for the mask that you can create for this, the blue section in the screen, and also some more options like the auxiliary output event if it's a fail or it's a pass if it reaches this blue zone, the polarity if it's positive or negative, the pulse time, and also what to do in case of error. So in this case I will have a stop and it will beep, but you can also take a screenshot and, for example, don't stop or just beep if it passes. If you do just beep and this does a lot of sequences, it will be quite annoying. So we will test both, but I want to show you also that we have these create, load and save patterns or masks. And since we have a sine wave on the screen, I will do a create. Okay, now that we have the sine wave and the mask around it, we can start the operation. And when we start the operation, let's just do a beep here also. Let's see. Okay, and if I do a minimize of the window, it will go to this section in the screen. I want to change the sine wave, but since I'm using this function generator, the built-in function generator, it will not be possible. So what I will do is stop this, and everything right now it's on hold, and then I can change now the sine wave to 3 volts of amplitude. Okay, as you can see, let me take the window of the screen. As you can see, if you change the amplitude, it will automatically fail in some degree. Okay, let's start again, and it was immediately reported an error. It beeped and it stopped. That's what we configure in the options. Let's see what were the options. How do we go back? Close. Not close, I want to go back. Okay, so we have to do it again. But in the options, what we had is beep and stop. If we don't have the stop, it will keep beeping, and this is a bit annoying. But at the same time, you can see immediately the fails going on here in the stats. Okay, we have to close. If you want, you can also do a beep and take a screenshot. Let's do it. It stopped and it's saved. And if you want to see the image that was saved, you come here to the storage disk and you will have it in here. Yeah, that's a nice feature. Let's close this and continue. But in terms of the pass and fail function, that's what I have to show you also. I will now show you the plotting function. For that, I have my board already configured. The signal from the function generator will enter here in term-in. We have the probe number of channel 1 on the in, and we are testing a low pass on the out. So everything is connected. Let's now open the Bode plot analysis. For that, we have this icon in here. Let's starting by activating the Bode plot. These now have several options. You can show the gain curve and the phase curve. The channel for input analysis is channel 1. Channel 2 will analyze the output. Also, we are using the signal or function generator number 1 with an impedance of 50 ohms. The sweep will be logarithmic and the display will be a curve. We can also configure some options here in amplitude frequency and settings. The start frequency of this board is 200 Hz and the stop frequency is 10 MHz. Okay, we can do like 10 MHz. And the remaining configuration is the points and amplitude on each step. The saving, we can save this for CSV or HTML, the name that you want to save and where you will be saving. In this case, we only have the local disk. Okay, you can also load the data from a previous save in CSV format. Okay, let's leave this for now and let's start the bot plotting. Okay, it's running. This will take a bit to conclude. Okay. We can see the signal changing, the waveform changing on the top in the zoom function. And yeah, it's almost done. Okay, yeah, and it's done. So you have here the Bode plot of this analysis, but we can also, instead of doing a graph, we can do a chart. In terms of the chart, let's see what we get. So the signal analyzed is basically the same, but instead of plotting a line in a graphic, you will have the values in a table for analysis. That if you want to see the values, it's much more convenient, and all the steps that you have with the bandwidth, the decibels and the phase in the last column. Okay, this should be almost done. Let me see, and we had 48 records up to the 10 megahertz. Okay, and this is the bot plotting. You can also, instead of having the curve logarithmic, you can have a line, and it works great. So in terms of bot plotting, this is what I have to show you. I have on the screen a waveform that I use to test the duration trigger, and let me pause this. If I want to identify this pattern, okay, and count the amount of times it happens in a signal, I have available a function. Let me go here. That is the search function. So the search function will allow you to search a pattern in the signal. It can be a pulse or it can be an edge. If it is an edge, you can identify the source of the signal. If it is rising, falling, or either. Okay, so this is pretty standard. We saw this already also in the trigger. And we can set a threshold. Also, we can open a mark table to show the results. We can export this to trigger, save the events to the local disk or a pen if you have, or don't forget we have also the SMB folder in this device that we can use. And you can import from trigger also. And finally, you are able also to use the navigation to see the results. Okay, going back here, so I want to deal with a pulse. And for the pulse, I have here 1.60, I believe, volts for the edge. And I want to trigger this, well, this is not really a trigger, but I want to identify all the signals that have the upper limit of 60 microseconds and the lower limit of 50 microseconds. So now let me activate the mark table. Okay, it shows here. And right now we are able to see all the matches that are higher or equal to 50 microseconds and lower than 60 microseconds. So we are able to do all of this search, and you can obviously write this to a disk to save the information. You can save it to CSV, basically. So this is what you can do with the search function. Let me just change this to edge. And now you are able to see the hits on the rising edge or the falling edge also, or both that happen in this waveform. Okay, in terms of the search function, that's it. Let's move on. So in this chapter, I will use this signal that you see on the screen to show you two functions. The first one is the roll modes, and right now I have the signal stopped, but if I start the signal, you can see that it's in the rolling mode. Okay, we can open the signal up to 20 milliseconds. That's when it starts rolling, at 50, sorry. And yeah, this is the roll mode on the device, pretty smooth. Okay, now that we have the roll function shown, I have to increase a bit the speed of the signal so we can use the record function. Otherwise it will say that it's not available. I can show you. If I try to activate, it says operation disabled. So I will increase the speed. Right now it's a bit faster. Still not possible, so let me change the time division. Okay, we have a new time division. Now we can activate the record. So right now we are saving 992 frames. Let's see what is the maximum. For the memory that we are using, 10K right now, we are able to save 63,488 frames. But I think that if we go lower, like 1K in terms of memory, we will be able, let's see, to save more, like 507. So as you can see, the memory depth that you are using interferes directly with the number of frames that you can use here. But I just want like 100 frames. So the interval will be 10 nanoseconds. We have here the max frames available. If we want a beep, we can minimize this for this menu. The problem is to maximize. I had this problem before. Max, okay, it's like this. We are okay to go, I think. Let's start recording. So as you can see, we are now recording the signal. It will take a maximum of 100 frames. Yeah, 100 frames. So what can we do with this right now? We can do a play of what we saved, and we can go frame by frame to the right or to the left, so forward or backward, to the beginning and to the end of the signal. So we still have two options in here, that is, this is play once or loop play, and you can go from left to right or right to left in terms of playing the frames. You can save what you recorded in the storage. You have here the data source, okay, screen, memory, and you are able to save it to the local disk, SMB, or if you have a pen connected to the pen. I will not do that right now. Let me go back to records, and in terms of the record function, that's it. I believe that my device had a small player. I was trying to show that, but we don't have here those options. Or maybe we have it. Let's see what we have in here. Okay, we have here the play controls, and yeah, here it is, the play. Okay, and we are going up to the 100 frames. Very nice. And maximize goes again to this window. This is the wave recording function, and yeah, pretty useful. Let's move on. And to test the XY mode, I will use my RIGOL DG922 Pro, and I'm using my function generator instead of the internal function generators of the MHO98, just because it is easier for me to control the signal instead of always being activating here the window of the signal generator and taking the things out of the image. To activate the XY mode, you come to the horizontal menu, just click here on the top, and you have here in this menu the XY option with a checkbox. Let's check it, and immediately opens this second window. As you can see, we have already a circle here. To animate the circle, we just change the values slightly. And as you can see, I still have the persistence on this channel. That's why you see this drag, this afterglow. And let me just give some transformations here in the circle just to create different forms. It renders pretty nice, but it has very thin lines, maybe because we are using such a high frequency. Not sure yet, but yeah, it has a very thin lines. Okay, let me change this to 3 kappa hertz, and on channel 1 kappa hertz to see if the signal will be better. And we just need to animate this. Yeah, we still have very thin lines. As you can see, they are almost imperceptible in the screen. This should be improved. Okay, the circle, yeah, it renders pretty well. Okay, we can increase the window, but even so, yeah, with more space you have better view. But even so, let me take this one out of the screen. Now with more space you have a better view of the rendering, but even so, the lines disappear. So this is not desirable, but other than this, the signal is very smooth. Yeah. Okay, this is the XY mode, nothing else to show you. To use the persistence is very easy. Just come here to the hamburger menu, and you have here the persistence time available. So you can set from minimum, that is nothing, to 100 milliseconds, 200, 500 milliseconds. You can see a drag already. 1 second. Okay, and on the screen you are able to see a drag in the signal. 2 seconds, 5 seconds, 10 seconds, it will show clearly the drag, and infinite. Okay, and to demonstrate this, I will close channel 2, and on channel 1, let's do a sweep. Well, this is just to show you the persistence usage, and I think that's it. To show you the color grading, I have already a sine wave on the screen that I will modulate. So let me start by modulating the sine wave. We are going to adjust the time division. Let's see, yeah, like this, and play around with the trigger more or less. As you can see right now, we have this waveform on the screen. And we can activate now the color grade, now or before, doesn't matter. But you can see here the hotspots and the configuration that is made with the colors. Okay, so it has a very nice progression. If you see the image that comes from the HDMI, you can see that the definition is pretty good. The progression, the levels. So this is how the color grading looks on the MHO98. Well, nothing really more to show. If I take this out, do an auto for quicker setup, you can see here the grading. We can even put again some persistence and do a sweep. Okay, and here you have a sweep with color grading also. Okay, in terms of color grading, that's what I have to show you. Let me move on. Let's now talk a bit about memory navigation and the zoom function. For the memory navigation, as I've shown you before, using this arrow on the top of the screen, you are able to navigate in the memory of the device, and also by using this knob on the oscilloscope keypad. So if you want to go directly to the center, just double click and it will center again in the memory. The memory itself, right now we are using 100 megapoints of memory, and you can go up to 500 megapoints in terms of memory. For navigating the memory, you can use also the zoom that will allow you to see the signal in a much better resolution. When you change the time divisions, you can see here in the zoom where the area that appears on the bottom is selected. So if you change the time division for a higher time, you can see that the scale opens up. Also, you can use the mouse to navigate in here with the scale. Okay, pretty easy to use, and as you move, you can see obviously the signal below adjusting to the point where you are. Okay, in terms of the memory navigation and the zoom, that's it. You activate the zoom as I've shown here on the horizontal menu option zoom, and to disable, just put it off. Okay, pretty simple, pretty useful. Let me now show you a bit more about the signal generator that is built in on this device. We have two independent signal generators of 100 megahertz each. To activate it, you have here a G key on the keypad, okay, that opens the menu, or you can go directly using the mouse or the finger to the option and activate directly the signal generator 1 or 2. You have here the options, these vertical tabs to change the options. And in terms of what you can do with this signal generator, you have a few waveform types like sine, square, ramp, noise, DC, arbitrary, exponential rise, exponential fall, SEG, Gauss, Lorentz, Avers sine, and sync. You have like 13 different waveforms to use. In terms of the frequency, you can select frequency or period, and it can go up to, not here yet, you can go up to, let's see, 110 megahertz. Okay, the square wave can go up to 20 megahertz. The sine wave should go around 100 megahertz, yeah. And you can go up to, I don't know the voltage, but let's see, it's 15 volts just to see the maximum. Okay, the maximum is 10 volts at 100 megahertz. And you can set the offset also, align the phase, and change the impedance to load 50 ohms or to high Z. I don't know if you noticed, but when we changed to load, this dropped to 5 volts. We can also align phase between the signals of the generator 1 and 2. We can also use the modulation. In terms of modulation, you have AM, FM, and PM. And in terms of AM, you have 6 different shapes for the modulation. You can control the depth and also the frequency. Let's see, for example, FM. Also the same, but in this case, you have the deviation and also the frequency. And for PM, you have the phase deviation also and the PM frequency. It is pretty simple, but it will give you all the tools you need up to 100 megahertz, and that's not bad at all. If you consider what is the price of a 100 megahertz dual channel signal generator, you will see that this is a bargain. Now let me show you how the remote access works. Let me just connect this Ethernet cable here on the back. Okay. And as soon you connect the Ethernet cable, the IP will be assigned. In this case, it is not yet detected. And here it is. As soon as you have this IP is assigned, if you are using the HCP, and if you can see here in the bottom, you have also the LXI logo. And I think that is something cool here. Okay, it detected immediately that you have an update to do. I will do this in another chapter. So as you can see, you have here now all the information about the network. And if you come to a web browser, You just input the IP that in my case ends in 240, and you are able to access the RIGOL remote web page. So it's a pretty simple interface, but it will allow you to do everything you need in terms of this interface. You have also this page with all the information about the device. Mine is the MHO98. If you press here in the web identification indicator, you will see on the screen of the oscilloscope a message saying it is connected. So you can, if you have several, you can identify which unit you are accessing. Also, you have a web control interface. You can see here, for example, I will move the signal. This is a web-based interface to access remotely to the device. You can do everything you do while working with the touchpad. You have all the controls in here. It works pretty well. It's very nice to have. Also, you have this print screen menu that will allow you to take a screenshot of what is on the screen, and you can save it to your computer. And you are able also to record the screen. Right now it's recording. I'm not sure how much time you can record, but anything you will do, for example, right now I'm using the menu to access, I don't know, measurements or something like that, and everything will be recorded. To stop, just press the button and you can do a download of what you just recorded. Also available is the network status. This page will show you the network configuration, and you have also the network settings. This page normally is password protected, but I already inserted the first time I came here, so the username is admin and the password is RIGOL. And this page will allow you to change the configuration of the device. So the next option is the SCPI panel control. It allows you to send SCPI controls to the oscilloscope, and then it will show you the answer that is returned. You have also the security to put a new password on the device, and finally it will have a shortcut to the RIGOL website. Okay, it's taking a bit. Yeah, here it is, the MHO98. So in this landing page you can see the MHO98 Special Edition on the left, and on the right you have the standard edition. It starts with a 300 MHz speed to 500 and 800 MHz top. Also, the signal generator has the option of 50 or 100 MHz, and you don't have all the options activated, as also the logic analyzer probe is not included. So the MHO98 is really a good purchase if you can get one. Okay, that's it in terms of the remote control. That's what I have to show you. Let's move on. As soon as I connected the MHO98 to the network, this dot appear in this menu, and if you press in the dot you can see that an upgrade is available. Let's click it. Okay, and he basically asks if I want to upgrade the system firmware. Yes, I do. Let's go. Okay, online, I accept, and he is right now upgrading the firmware. This might take a while, so let's fast forward. So now it's booting up. Okay, should be almost done. Let's wait. Here we have it. Seems that everything is working as it is supposed to. Let's do an auto. And let's see the version that we have right now. It's the version 1.0. The build still from 24th September. And yeah, launcher and web control updated. Okay, that's it. Let's move on. Something really cool about these new generation oscilloscopes is the HDMI output. You have it here on the back. Just with a normal HDMI cable, you are able to connect, for example, a monitor like this, and you will be able to see everything that is displayed on the screen in a monitor like this. On the bench I have this 21 inches monitor, and everything that is displayed on the oscilloscope screen will appear on the monitor as it should. The resolution is pretty good. We don't see squares or anything, so I'm quite happy with this feature. Okay, this is the HDMI output, and another thing that is pretty cool, let me take this out of the way for now, is the VESA mount. Let me get mine. Right now it's mounted on this bracket where you can adjust any position that you need and bring it up to the front. You have this same VESA screw mount on the MHO98 and 900 series, and you can use this mount to install the oscilloscope. And that is actually what will happen, since this place it's the new home of this MHO98. After putting the MHO98 through all its spaces, here's where I land on this instrument. Let's start with the aesthetics. The retro or vintage look is absolutely stunning. That semi-transparent rear panel showing the internals, the brushed metal knobs, the gold nameplate. It's not just functional, it's a piece of art, obviously, in my opinion. It really stands apart visually from the sea of black boxes on the test bench, and some white boxes too. And it's not just style, the chassis feels solid, the knobs feel precise, and the touchscreen plus the physical controls complement each other nicely. RIGOL managed to deliver a beautiful balance of modern features with a touch of classic instrumentation charm. Talking a bit about features and capabilities, this is where the MHO98 truly shines. Everything is here. So you get 4 analog channels, 16 digital channels MSO, ideal for mixed signal debugging, 1 GHz analog bandwidth and 4 gigasamples per second real-time sampling rate. You have also 500 million points of memory depth for deep captures. Dual channel 100 MHz function waveform generators built in. All licenses and options included serial protocol decoders with I2C, SPI, UART, CAN, LIN, audio and more. Bot plot mode, FFT, search and zoom functions, math operation, XY mode, advanced triggering, including edge pulse window runt and more. Ultra acquire mode with waveform capture rate up to 1 million waveforms per second. It supports Bode plot analysis integrated with the signal generator. And it is powered by USB Type-C, so it can be powered by any modern portable power supply or even a good power bank. It has a 7 inches HD multi-touch display up to 1024 by 600 pixels, and for last a fast front panel navigation scheme, nice graphic responsiveness and a strong mixed signal correlation tools. In short, it's not missing anything you'd expect in a high-end scope. RIGOL held nothing back on this limited edition. In terms of performance, the frequency response was solid, triggering was sharp, and the signal generator outputs were clean. And the memory depth let me capture long bursts without compromising the resolution. The digital channels with the logic analyzer probe synchronize perfectly, which is critical when debugging mixed analog-digital systems. In FFT mode, the noise floor is impressively low thanks to the 12-bit resolution, which helps in analyzing small signals or harmonics. Advanced triggering and search, waveform recording and zoom tools made navigating captures very efficient. If you are comparing the price and value, this is a rare opportunity. So now let's talk about the price, because this is where the MHO98 becomes truly compelling. It's listed in Europe for around 1,099 euros excluding VAT for a fully loaded unit with 1 GHz bandwidth, 4 gigasamples per second of sampling rate, 4 channels, a dual 100 MHz signal generator, a 16-channel logic analyzer probe, and all license included. For what you're getting, that's an absolute bargain. Features that would often cost extra add-ons in other scopes are included outright. This is one of those once-in-a-lifetime opportunities where you essentially get a flagship, no compromise instrument at a relatively moderate price. Even the standard production MHO900 models with the 4 gigasamples per second sampling rate and the same architecture become amazing deals in their own right. You trade a bit of bandwidth but retain the core high-res ADC, mixed signal support and rich feature set. The MHO900 series philosophy is strong, bring high-resolution deep memory and full mixed signal capabilities to more accessible tiers. So to wrap up, the construction and design are excellent with that eye-catching retro aesthetic. All major features are present: signal generator, deep memory, protocol decoding, search, zoom, XY, FFT, advanced triggering, and so on. The performance is rock solid across analog, digital, the function generator, and mixed signal tasks. The price is aggressive given what's included. You are getting a flagship performance at a price that wouldn't often only get you a mid-tier model elsewhere. The full unlocked license approach is refreshing, no waiting or paying for software options or unlocks later. Even the MHO900 series models are very competitive when you look at what they deliver. If you are serious about pushing signals in development, mixed signals designs, or just want an instrument that can grow with your projects, the RIGOL MHO98 is a standout. It's one of those rare releases where it's hard to find meaningful compromise given what you pay. If you like this review, please remember to use the affiliate access links on the screen or in the video description when purchasing on AliExpress or Amazon. It won't cost you a cent more, but it helps to keep these reviews coming. And if this video was helpful, smash that like button, and if you are new here, subscribe so you don't miss the next deep dive into test equipment and electronics tools. That's it for today. Thank you for watching, thank you for your time and company, and I'll see you in the next one. Until then, take care and happy measuring!